Welcome back. In this notes, we're going to continue addressing completing the square to get a little bit more practice. Now, there is a new issue we're going to bring up that we didn't discuss in the previous lesson. And this is the idea that the x squared term actually can't have a coefficient. It can't have a number that's with it. So if there is a number that's with it, you actually have to divide it out. Okay? So I want you to take a look at these. So these are quadratics that can't be factored, can't use solving by square rooting, so we need completing the square. But there is a 2 with the x squared. So what you need to do is divide every term by 2. Divide both sides of the equation. Divide everything by 2. So we'll have x squared plus 6x plus 3. 0 divided by anything is still 0. Okay, so if there's any number with the x squared, for this completing the square process, get rid of it. Just divide it off. And now it's going to be exactly the same as what we discussed in the previous notes. So let's review what that looks like. Okay, so I'm going to subtract off the constant term. Remember, we move the constant term to the other side. Now we identify that b term, so that term with the x. And remember, we take b divided by 2 squared. So remember, I always do a little side work over here to get to that number. Once I get that magic number, I'm going to add to both sides. Okay, and the reason that I'm doing that, the reason I add it to both sides, is because now this side factors. Two things that multiply to 9 and add to 6, well, you're talking about 3 and 3. And on this side, negative 3 plus 9 is just 6. All right, now remember, this always factors in such a special way that they're actually always the same thing. So I'm always going to transform that those parentheses into a single one. I'm going to call that x plus 3 squared, because now that allows me to square root both sides. So the square root is going to undo the square. Oh, I'm sorry. It undoes the square and then leaves you with plus or minus the square root on the other side. Again, be very careful. Please don't forget the plus or minus. That is a big deal. And again, I did put that on your checklist in the previous lesson. So as you're going through, if you still want to have that checklist out, that step-by-step process, that may be a good idea. Once you get to this point, now you subtract off the 3, still have the plus or minus square root of 6, and that's going to be the end of your problem. That is your answer. All right, and again, I just want to make sure that you see a couple more examples just to make sure that this is really solidifying for you. So I'm going to move this up so I have a little bit more space. But here I see a 3 with my x squared. So I'm going to divide everything by 3. That's going to leave me an x squared minus 8x minus 1, and then 0 divided by any number is still 0. So now I have the setup that I need to complete the square. First step, move the constant term to the other side. So I'm going to add that 1 over to my other side. Next step, I identify my b. So here my b is negative 8, again that number with the x. And I'm going to do a little scratch work over here because of that little formula, b over 2 squared. So negative 4 squared, or we get 16. Once I have that magic number, that's what I add to both sides of my equation. And the reason I'm doing that is now this side factors x minus 4, x minus 4. Remember, two negatives is how you multiply to a positive and yet add to a negative. Then that side you get 17. And again, the trick to this is you should always get some of the factors in such a special way that the two parentheses are the same. So I can rewrite those parentheses as x minus 4 quantity squared. And the reason that I do that is now I can square root both sides. The square root will undo my square and leave me with plus or minus square root on the other side. Again, please never forget that square root. And now finally, to get x by itself, to officially solve for x, I need to add the 4 over to the other side. And that is going to be the final answer. All right, so there is one other thing I want to cover briefly with you. It's skills you already have, however, something I want to address in this context. So I'm going to begin solving this exactly like I have been previously. Now, note here that x squared already doesn't have a number with it, so I don't have to worry about that piece. So all I'm going to worry about is moving that 8 over. It's going to add the 8 over. Take that b term. I'm going to do my little scratch work over here. Take that term, divide it by 2, and square it. Well, 2 squared is 4. So I take that magic number of 4 and I add it to both sides of my equation. This side ends up factoring for me. And again, it's always going to factor in such a way that you get the same thing in both parentheses. Then 8 plus 4 just gives you 12. Because these are the same, I'm going to write them as a single term squared. And now that I have it written that way, now I can square root both sides. Well, square rooting a square just leaves me what I had inside the square root, or inside the square, and then plus or minus the square root of 12, and subtract the 2 over. Now, the thing I want you to catch is in this case, that square root of 12 that you see. There's actually a perfect square that can pull out of that square root of 12. So the thing I want you to also remember is if it just so happens that the radical can simplify, I do want you to use that skill that I've already taught you. Okay? I do want you to split up that 12 into 4 and 3. Pull out that perfect square. And then call that 2 to simplify it. So, just again, it's a skill you already have. I just want to make sure that you remember that if you get a radical that can simplify, it is my expectation that you do so, that you actually simplify it. So with that, that is going to be the end of these notes. So thank you for joining me. Please make sure you have all this written down and come and see me if you still have any questions.